So starting with the sinusoidal response of RL circuits, as I have already told you, phasor relationship, currents and voltage. So girls, we know that I lags VL by 90, or oppositely we can say VL leads the current by 90. So girls, you see here, we have a current of RC circuit which is flowing, and you know that we are also in the same phase, yani VR and I, they will start same time and they will complete the cycle same time, which we know already, right? Now, in terms of VL, and I told you VL is 90 here leading. So it will start and touch the positive y-axis. So it is what? It is a start here like that. So hope it is clear to all of you. Phase relationship between VR, between V and VL. Is it clear, this phasor diagram accordingly? Amplitude will vary definitely, because VR is what? It is a multiplication of current and resistance. So its amplitude is high. That's why. And if we are showing this amplitude, because VL will be calculated I into XL. So their amplitude will change according to the values. This one. All right, guys. Is it clear? This diagram to all of you?
Yes, clear.
Okay, leading and lagging bus. All right. So now this is the phasor diagram which I already explained to you. Now you can understand again one more time quickly. So you know that I and V are always in phase. So I is here, or we can say VR is here, so VL will be here. So they are saying out of phase how much? 90 current and voltage, and they are in phase. Now we try to draw the composite phasor diagram, and how it is gonna be. VR will be on the x-axis, VL will be on the y-axis, and we can have VS. So theta will be VL over VR. And guys, can we apply the Pythagoras theorem here also? So we can say VS square is equal to VR square plus VL square. You know the change, but this is change here. For capacitor it was VC. Here we have VL. That is the change. And we can also write this one, that. So exactly same thing, girls. Only change is the diagram is upside down. First of all, phasor diagram, but calculation of theta is same. Calculation of Vs and relation. This formula is exactly same. Now, guys, so this is impedance, and I already told you about the impedance phasor diagram. This is the impedance phasor diagram. R will be here, X will be here, and this is gonna be Z, girls, and theta will be calculated XL over R. Believe it is also clear to you now. This is what we call triangle. Okay, it's same thing. This is called phasor, and this is called triangle. So Z, R, and XL. This is already explained. Now, girls, question, just simple question. If R is this, XL is this, calculate, sketch the impedance triangle. Okay, I can sketch, because this is gonna be R, so I can write this is R. Okay, this is XL. Okay, I know this is gonna be XL, 960 ohm. Okay, now this is gonna be Z. So Z I can calculate by the formula. What was that? Z is equal to under root R square plus XL square. That's it. Okay, this is the way. See the solution.
Doctor,
Yes.
here he didn't say that this is an RL circuit. How am I supposed to know?
You will know by looking to this.
Oh, okay.
Okay, XL and XC will tell you bus. Okay. Okay, so this is the way, and theta we can calculate this way, and this is my final. Okay. Now, girls, so these again Ohm's law, girls, you know already. V is equal to I into Z, I is equal to V into Z, Z is equal to V into I. Exactly same thing, which you know already. Now, see this question. The current in this figure is 200 microampere. Determine the source voltage. So current is given, source voltage you have to find. Now tell me the steps, girls. What should I do? Okay, XL. What is the formula? 2 pi FL, right? 2 pi, I'm just writing this way, 2 pi FL. This is the formula, right? Now, after that, we need to find Z, correct? All right. So for the Z, we can say Z is equal to under root R square plus XL square. By the way, it is gonna be same XC square or XL square. So calculate the Z. After calculating this one, I need to calculate the source voltage. Okay, V is equal to I into Z. So I we have given already 200 micro 10 raised to power minus 6, and then we will put value of Z. Sorry, Z. That's it. Then I can get this one. Okay. So this type of questions are there. So what is the change on here? Only how you will calculate the XL, which is 2 pi FL. Rest is all the numeric formulas, Ohm's law or Pythagoras, any vector sum is there already. Now, guys, hope you remember this similar slide there. Effect of frequency over variation of this one. So it is again, we can easily analyze this one if we write the formulas. What was the formula? First formula is XL, which is 2 pi FL. Okay, another thing is what we can find after this one, Z. What is the Z? Z we wrote here R square plus XL square. Then what was that? Next, theta. That is tan inverse XL over R novels. So see the variation of the frequency here. So girls, if the frequency increases here, do you think XL will also increase? Okay, it's because proportional, correct? So if XL is increasing in this factor, girls, so Z will also increase. If Z is increasing, okay, and XL is increasing here, so theta is also increasing. That's it. So you can see now. So this is initially we have R, we have XL for a lower frequency, and we have Z1 because they are saying frequency is increasing as we are approaching up. So here is less frequency. Yani this is F1, which is less than the F2, which is here, and which is F2 is less than F3, which is here. So at lower frequency, we have this triangle. This is the theta 1, this is the Z1, this is the R, this is XL. Now I increase the frequency and I reach here. So as I increase the frequency, you will see XL is increasing. Now it is XL2. Z is increasing. You can see the vector length. It is telling that it is more. And you can see the theta. It is also more. We further increase it and we will find that this is the theta, this is the Z, this is that one. So what is that? This concept exactly same which was there for the XRC circuit. By increasing the frequency, all factor is increasing. But I think there all factor was decreasing, right? What was that?
Sorry.
That one, right? So yeah, this is the concept here. There. Let's just draw the XC. I told that was oppositely there. Yani by increasing that frequency, all the factor was decreasing. But here, all the factors are here increasing. Parameters are increasing. So it is opposite, yes. All right. So you can just make a note here. This is the opposite in case of RC circuit. That's it. All right. See a few more questions. So here for the RL circuit, determine the impedance and phase angle. Girls, it is the exactly same question if you remember. This is 10 kilohertz and 20 kilohertz. Yani we are going to prove that by increasing the frequency, the factors are also, the parameters are also increasing. So it's all about that. So first R is given, L is given. So we will try to find XL, very first thing. Then we will calculate the Z by the formula vector sum. Then we will calculate the theta, right? This is for frequency 10 kilohertz. Now we change the frequency to 20 kilohertz and I check these things. And what I found that XL is increasing. Previously it is 1.26, now it is 5. Okay, this is here and this is here. So it is just a proof what we conclude in the previous slide that by increasing the frequency, other parameters will also increase. That's it. All right. Okay. So, girls, impedance and phase angle of a parallel RL circuit. So it is about parallel. Previously that was for series. Now we are discussing parallel. So girls, parallel. You remember that in the parallel circuits, how do we calculate the total, resistance? We calculate by product over sum. Remember formula? It is exactly same product over vector sum. So rather than Rxc over R square plus Xc square, I am writing exactly same formula, but Xc is replaced by XL. Same formula you learn for the RC circuit. It is exactly same. Do you also remember the theta? I told you girls it is gonna be reverse, yani R over Xc there for the parallel circuits. Same is here, R over rather than Xc, we are writing XL. Did you remind these things? Right? Formula is exactly same. Only change XL is replaced by XC. Correct? This is something. So now, see now. So sinusoidal response for the parallel RC circuit. So girls, do you also remember the concept of conductance? R is equal to 1, G is equal to 1 over R. Similarly, inductive susceptance, we discussed there, capacitive susceptance, right? Exactly same. Rather than BC, we are using the word BL. So you can just look the suffix and you will understand that whether I'm talking about inductive circuit or capacitive circuit. So this is what. Third one, admittance, which is the inverse of the impedance. Exactly same. If you just keep both the slides, it is gonna be same. And hope you remember the power factor also. So what was the power factor? PF is equal to cos theta. That's like that, right? So the power factor was discussed in chapter 15 and recall RL with RC. Recall that relationship between the apparent power to the volt ampere. True power is watt. Volt ampere multiply the power factor equal to the true power. So exactly same formulas here what I'm going to discuss. Now see this question. Determine the power factor, true power, reactive power, and apparent power. Apparent power, do you remember? Apparent power is the overall power. So we know the true power, we know the reactive power, and apparent power is the overall power. All right, see now. So first we need to find the power factor. So we have given XL already, girls. So it's good. We don't need to calculate the XL. So we can calculate theta is equal to R over XL this way, right? So the impedance of the circuit is, because it is a series circuit, girls, so I can calculate the impedance this way. Then I can calculate the current Vs over Z. This is the way. Then I can say theta is equal to XL over R. Why I'm using XL over R? Because the circuit is series. That's why. Okay. So this is here. Now power factor formula is cos theta. So I will put the theta value and I will calculate it here 0.448. Now we need to calculate the true power. So girls, true power. Can you see this one? What is that one? This is inductive reactance actually, which we know. So now they are asking true power. So true power, either I should know what RW, winding resistance, or true power can also be calculated by this formula if you know the power factor, which is P true is equal to VSI into cos theta. This is exactly same formula which we discussed there. So either we can calculate I square into RW, or we can calculate VSI cos theta, because we did given is this time RW, because we know the power factor, so we can apply that formula, which is now 10 volts, this one, and 20 milliwatt is the answer. Now, for the PR, this is what I square into XL. or true power will can also be calculated this way, you know, because we are, you know, in this circuit we have resistance already, girls. So even Rw is not given. Rw is required when we have only the inductance in the circuit, but we have already resistance here. So true power will be consumed in this resistance. So Rw is not mentioned, khalas, we don't need, but we have this one, yeah. So this is there. So I square into R. So this will can also be calculated either this way or this way. Yesterday we did, okay, yeah. Then apparent power. Apparent power is, girls, you know that overall power. So it is the sum of vector sum of true power plus reactive power. Same formula. P true square plus PR square. So we can keep it here and we can calculate that. So one question, yani, at least you should revise this one. I'm not saying yani, you solve multiple, but you revise it. So that will be sufficient for you. That's it. So this